Thank you, and welcome to everyone. We have an excellent panel of actually experts that actually care about actually data science, privacy, fairness, and education. My name is Neil Heffernan. I'm a professor at Worcester Polytechnic Institute, and I'm just going to be moderating a session. I'd like to get actually our panel to actually briefly introduce themselves. And let me start with Kathi Fisler. Professor Fisler, Kathi, can you introduce yourself?
Hi, I'm Kathi Fisler. I am a professor of computer science at Brown University. I'm also co-director of Bootstrap, which is a national scale outreach program for K-12 computing integrated with math, statistics, and data science.
Excellent. How about Emma? Can you introduce yourself, please?
Hi, I'm Emma Brunskill. I'm an assistant professor of computer science at Stanford University. I'm delighted to be part of this panel today. My work focuses on reinforcement learning, which is a part of artificial intelligence, in which agents learn by trial and error how to make good decisions. And I think about applications of that to education and healthcare.
Excellent, great. Osonde, can you introduce yourself?
Hi, everybody. I'm Osonde Osoba. I am a senior information scientist at the RAND Corporation, and I also teach at the Pardee RAND Graduate School for Public Policy. A lot of my work at RAND has been focused on thinking through the applications of machine learning to decision-making in government, and also thinking through the implications of the existence of machine learning decision support tools in policy settings.
Excellent. So we are here at the NeurIPS actually conference, right? That actually has a bunch of really great experts that are often not actually studying actually educational context. And I'd like to just get actually each of you to reflect a little bit on actually with the experts that we actually have here at NeurIPS, like how can we actually get them excited about these educational ideas that we are excited about? And let me just go like in reverse order. And like Osonde, like how is actually your type of work actually that you've done in the past actually maybe relevant, and or actually how do you think actually we should actually try to pose interesting challenges to the field that would actually help actually us do something interesting in education?
So education is a tough area in terms of policy, in terms of thinking through the applications of machine learning for. One of the things I found in my work on interdisciplinary analysis, the interdisciplinary use of machine learning for policy has always been this idea of having a multidisciplinary team of experts who can properly pose the education problems in a way that machine learning researchers can sort of design potential solutions around. That has been effective in a number of different policy areas. I think I'll leave it at that for now.
Excellent. Emma, what do you think?
So I think my vantage point comes from someone who I publish regularly in NeurIPS with my students and my postdocs. And so I think it's one of those things where I think the NeurIPS community is filled with a lot of really amazing, very technically brilliant people who do care deeply about applications as well as hard technical questions. And so I think if one can pose either technical questions which show the limitations of the field, that can be really exciting to people because then they know, hey, there's something we can't solve with our existing methods. We need new, ideas to tackle that, and that can be one way to make people excited about this field. But I also think other things like data sets, and Neil, you've been instrumental in this, and other people too, just like ImageNet, data sets bring people as a place to be able to measure progress and compare. And so I think both data sets and test beds, I think one thing historically for education that can be a challenge is doing experiments and trying new things out. And it's much easier to do that with, video games or things like that, where you can just kind of run it on your computer compared to interacting with real students. So I think the more also that the education community or schools can, sometimes be offered as places for us to try things out when we think that there might be new things that could work well. That's another really exciting possibility for the field.
Thank you. Yeah, Kathi, I'm curious to know what you think, and you should probably expound a little bit more on actually Bootstrap, because if we're ever going to get lots of actually people and maybe a more diverse actually audience here at NeurIPS, actually speaking minorities and actually females, making that pipeline actually bigger and more robust, actually, I know your project is geared up towards. So what do you think about these issues?
I think you've probably asked me an hour's worth of questions right there, but I'll keep it shorter than that. So,
okay.
you know, when I think about machine learning, and I've never been to NeurIPS, so this is my first time interacting with all of you. But when I think about education, one of the things I think about is how rich and varied the needs are for tooling and feedback in a field like education. So I think it's pretty easy for people to think just about instrumenting student-facing tools, for example, and say, hey, what can we learn to get the teacher either, you know, not a big dependent in the loop, for example. But I think that's missing a lot of what we know about education from a policy side, which is that teachers play a critical role in the classroom. So I think there are some interesting questions about how might you leverage something like machine learning to aid in teacher professional development, assuming that the teacher is going to be the primary instructional deliverer in a classroom instead of, say, an algorithm or a technology. So I think there are some really interesting questions there. I think there are questions about what's the right interaction between qualitative and quantitative analysis methods. A lot of the kind of research that we're going to need to make fundamental shifts in education still need qualitative kinds of methods. And so that interplay is really important. Neil asked me to say a little more about the Bootstrap project. What we're trying to do is a lot of professional development with teachers to help teachers primarily from disciplines like math or science or social studies learn enough computing to use computing as a context for teaching math and social studies and data analysis and science. So we're really looking also at how you get people who have expertise in one domain, namely, say, a math teacher, comfortable enough with a little bit of programming that they're teaching the students how to think about math through programming. Right? So these are some of the kinds of issues that come up. So I think there's a lot of questions about what the right role is for something like machine learning in that context. And I believe we're going to get to some of those as we go through the panel. So I'll leave it there for now.
Right. Neil, can I add on top of that?
Yes, please do.
Yeah, I think the point Kathi made about thinking carefully through the pipeline of decisions and service delivery in the education system, where does a teacher fit, how are students experiencing the learning experience, is important from a policy perspective, because if you think about what experts, machine learning experts, for example, have to offer to education policy, it's the development of tools to solve specific problems. But a myopic focus on specific problem areas is not going to solve any of the broader problems of education. So having the domain expertise to help think through how the different problems fit together, and domain expertise to also think through how the system sort of works as a whole is important too. So I just want to double down on that point. That systemic focus on the education delivery pipeline is more important in a sense than the actual machine learning expertise for solving individual problems. I know that's
speaking someone who's been, reviewed papers and proposals and things like that, I think we often see people coming in with proposals to apply machine learning to education without showing an understanding of that broader context. And I'm assuming, Osonde, you see that in the other areas, policy areas that you work in as well.
Yep.
So I think that would be a huge takeaway from this panel, is understand the context that you're applying to work in.
And I guess just maybe to jump in on that, I mean, I think the context is extremely important. I think it's hard for any of us to be an expert in one area, let alone many. And so I think one of the places which I try in my own work, and I'm sure many of you as well, is to collaborate. So I think if one starts to have teams of groups of people together who can then provide that complementary expertise, that can be really powerful. And I guess I think also maybe just to echo some of what was just said, I think one of the most exciting opportunities for AI machine learning is really thinking about human AI partnerships and like what can the teachers do really well versus what can the machine learning methods potentially bring to augment and amplify the work that the teachers are already doing. Because I have young kids. When I think about when, sort of even just 30 people, or let alone way more, my reinforcement learning class has about 250 people, it's impossible for me to kind of have a really nuanced model of what the knowledge state is of all of my 250 students. If I had machine learning methods that could say, hey, 60% of students didn't really understand this thing, you might want to focus on that in your lecture, or like, how do you design office hours? How can these kind of augment human capabilities? I think that could be really powerful.
I think get that from my classes. I have 375 people in my intro computer science, data science class this semester. And I would love
I think Kathi actually just went a little offline for a second. Kathi and I used to work together at Worcester Polytechnic Institute, and she's now at Brown. And I was talking to her about her cool project and its wide use. But let me actually come back to Emma for a second, because actually Kathi, Kathi, you're back, because we had lost you for 15 seconds. Let me come back to you, Kathi. Could you say that, please, again?
It broke about when you're saying you have about 375 students.
I'm sorry. Okay, so I have about 375 students in an intro computer science, data science combined class. And I would really like to know, how are they working through exercises? What are the common sticking points that students are having? So I would know which groups of students, say, to cluster together to work on certain things. But I don't want tooling to do that for me. I want the tooling to give me the kind of information I need to then reach out and build the relationships with the students to help them do that kind of work better.
What sort of stuff actually has the panel seen that actually particularly excites them more on this teacher side, right? Actually, I think earlier in the day in this panel, we will have heard from several people that actually have student-facing systems that actually make the student experience better. Anything that really impresses anyone on the teacher side?
Well, I think Ken Holstein's work is really exciting on this. So maybe for those of you who haven't heard of, or probably many people in the audience won't have. So Ken Holstein is now a professor at Carnegie Mellon University, and as part of his thesis, he did work on augmented reality. And so what they were doing is they were trying to track, as students were working on activities in their computers, kind of try to provide some of this information about what are people struggling with in a sort of a lightweight sort of augmented reality thing that someone could wear. And then that could be used for information to the teachers to help decide how best to either group students or who to maybe reach out to. And of course, there's a question, these devices are quite different looking. And so they also did a nice trial to see sort of even just wearing one of these, how much effect does that have? And does that make sort of students, does that change your interactions with students? So I think that type of stuff, it's still very early days, but that's an interesting idea of how could you sort of, whether for virtual reality or augmented reality or not, how could you kind of be augmenting the information teachers can use in real time to try to inform some of these classroom decisions? Because on the one hand, you do have quite a lot of time with students. On the other hand, it's fairly limited. And so how can we best leverage that time altogether, and also leverage all the sort of complementary capabilities of other students? Maybe we should pair up Jessica and Jerome. Maybe we should, how do we sort of create those dynamic groupings, both for identity, math identity, allowing people to take on different roles, as well as for sort of, cognitive improvement on particular skills.
Thank you for mentioning Ken Holstein, because I want to double down on his work. He was able to really show that by giving teachers this live data, he could get them to be closer to children that were struggling, right? Really demonstrating we could help close the achievement gaps. And I guess this is the first time we've even mentioned that should be one of our explicit goals, right? African-American scores over the last 15 years have hardly moved and remained stable, the white-black achievement gap. And there's a bunch of other achievement gaps that are been perniciously bad. And at least the data that that's coming out from Raj Chetty's group right now is making, and several others, it's going to get worse. It's going worse right now due to this pandemic, and it's the lower knowledge. It's the poorer kids in poorer districts that are not having experiences. Anyone else want to comment upon the achievement gap, or what they think we could do to address that?
This is entirely, I'm just picking up one of the points from Emma's discussion there. I don't know if you'll actually address the achievement gap, because I don't have enough empirical evidence on this, but there's the idea of, one of the points she made was this idea of forming teams. I'm extrapolating a little bit from what she said. Optimal team formation, essentially to help people get the most out of the interaction with other students. So it is, if you're trying to get an outcome where the class moves together in capacity, in competence. You have this natural dynamics where good students might end up forming teams together on projects. And if there was a way to try to target that goal of whole cohort moving together using a team dynamics, optimal team formation model, that might be interesting.
One thing I would throw in, because actually as Emma was describing Ken Holstein's work, which I'm actually not familiar with, one of the things I was thinking of is often when we're trying to support students in economically disadvantaged districts, technology itself is a real challenge, right? I mean, schools have things like Chromebooks and periodic access to machines. But I think a lot of times when we're thinking about technology-based solutions to help us with education, we're not always considering what the technological limitations are that might exist in a school district. So, I think that's a strong dose of reality that needs to come in here. And the other thing I'm thinking is, I read a lot about professional development, especially as it affects equity kinds of situations. And really the role of mathematical conversations, for example, is something that's generally viewed as critical to closing achievement gaps in mathematics. So I think there becomes a really interesting question there of what is an appropriate role for integrating something like machine learning into a process where that teacher to student and student to student communication are huge components of at least what we currently know about how students develop positive mathematical identities in education. So I think it's a fascinating open question with a lot of subtleties if we're trying to work on achievement gaps.
Can I also add a further point?
Please do.
So one of the frames, the lenses I take on whenever I'm faced with trying to address a policy problem is, first of all, I want more clarity, more situational awareness on the state of the problem. And then I want intelligent ways to map a state into an intervention to address the problem. And so in terms of our achievement gaps, there are technologies around early warning systems that can help identify which students are falling behind in the class. I think some of the work I've seen suggests that there is enough stuff going on there that we can actually get good technology rollouts there. The part I have trouble with, and this is not just in education, it's also in other data heavy approaches to solving other policy problems, like in the COVID case, is the mapping between what you observe as the problem, the state information, and what interventions to take in response to that. So you see students falling behind based on this technology solution to warn you early. What's the optimal solution? And because the way in which people fall behind might be very different, and it might not be very clear just knowing that they're falling behind what to do next. I haven't seen, maybe the rest of the panel knows more about the state of technology in this. The recommendations for interventions to help people who are identified as falling behind. I haven't seen that yet.
I think, to me, I mean, you guys may know more, it seems an incredibly complex issue. And it seems like we have some different examples where sometimes that works well, including in technology, but that it's highly context dependent. One of the types of interventions, which is not really machine learning, but is a technological intervention, which I think is interesting, is text message systems to parents. Again, sort of focusing on kind of this network of people that are involved in the education of children. And I found it really interesting that sometimes there is this sort of information asymmetry. So this was mostly done in LA. They found that a lot of parents didn't realize how many assignments their students were missing. This was for like 9th graders, early high school, or like how many absences they were having. And so they found that by leaving like targeted messages, they could have this is so they could have a small but significant impact on some of these outcome measures. And I think that was, again, that clearly won't impact students that, are homeless or, really experiencing extremely large difficulties and challenges, but there may be kind of that 20 to 40%. And my guess is that that's what we'll sort of have to do, and again, you guys probably know as much more, is that it'll be a context specific. There'll be different interventions that work well for different subpopulations, and that may have very different needs in terms of resources and cost effectiveness. And so it sort of will end up being kind of like an ensemble approach in terms of trying to be able to tackle these inequities. But I'd love to hear of other types of interventions people know of where they have been either surprised or delighted to see that it works well, because it's such a challenging problem.
Well, what I really like about the text messaging example too, is it's an example of finding out what the communication system is in place already, and then figuring out what to do to build around that, instead of building the solution and then trying to find a way to make it effective with schools. And I think that the text messaging is a really nice example of something in that space.
Well, and I think, Neil, your example, the work that you've done with ASSISTments is also, I mean, you've had some really amazing results in terms of the randomized control trials. And again, it's quite a lightweight intervention that really seems to be focused on, I'll let you explain it for the audience, because not everyone may be familiar, and it'd be crazy for me too, but I've been so impressed of like how this is very teacher focused, but is really sort of, you know, how do you do these homework? So maybe I think the audience would probably love to hear about that work, because that's also been very effective in terms of outcomes for students.
I was thinking of actually here. I'll come back to ASSISTments in a second, because like I was going to ask you folks if you guys know, because like thousands, millions of kids right now are in Zoom and are getting thrown into like little Zoom breakout rooms, and I start to think, and we are in a little Zoom breakout room, as it were, right? There's a big group going on. It happens to be the case that we've recorded this beforehand, but I just actually look and I think of what are all the different ways that AI might be able to help a teacher realize you have 6 breakout rooms all going on simultaneously, right? And actually, which breakout rooms, you know, do you have something going on? Maybe some AI should actually realize, oh, that Neil Heffernan kid, you probably need to send that kid a message, because all he seems to be doing is asking questions. He contributes nothing. But now I'm about to contribute something, because I know you put me on the spot. But I want to come back to like, just in the pandemic, thinking about like what are the things we could help teachers do. But since you threw me the softball of like the ASSISTments thing, it is the case that actually in 2016 there was a big randomized control trial done on the ASSISTments platform, and we did actually find a type of gap closing feature where actually kids below the median on their prior year test score actually learned twice as much as what you'd expect in a given year. The kids above the median still on the prior year test score still actually learned like 40% more than you'd expect. And we need more interventions that actually help close gaps actually. And kind of sadly, the What Works Clearinghouse, kind of the US standard for this sort of thing, doesn't even actually demand we actually track, hey, does your intervention actually at least not hurt kids, like for certain groups? It just seems so relevant this year, actually, with George Floyd and all the issues that we're actually experiencing as a country. It just seems like actually fairness seems really important. And I think we know there's probably lots of examples. I think many of us might be aware of, like Amazon had to get rid of their resume reviewer actually, because it was like biased, because it had been trained up on actually a bunch of actually white actually boys, I think actually men. Do you guys have thoughts on how do we make sure that we actually, as we build new technologies that might use some of these fancy techniques to somehow make sure we actually don't actually let actually biases creep in? Or is that a fool's errand? Is it like basically impossible to use some of these technologies without actually, that are trained up on systems? I don't know. What does the panel think?
I will say this is something, you know, more broadly in the machine learning community, it's something that for over the last 4 to 5 years, there's been a lot more awareness of this and a growing movement on sort of fairness, accountability, and transparency. I think it is challenging, but it's really important, and there has been a lot of progress made. I think in our own work, we've been thinking about if you know there are some things you want to avoid. So let's say, for example, we had a NeurIPS paper last year looking at how do you create like adaptive decision policies from old data in a way so that you don't accidentally create a policy that is systematically better, say, for women than for men. And so we actually it wasn't, like a full blown, it was none of the sort of sophistication of sort of a tutoring system that, many students use in classrooms, or some of you have developed, but it was a very small, lightweight demonstration of, if we had this little experiment where students were learning a task and we kind of systematically tried to inject bias, could we have an algorithm that kind of avoids the sort of policies that look like they're better kind of on an aggregate level, but actually are much worse for one group than for the other. And so I think that for some of those things, we are making progress. There are algorithms now, like ours, like others, which can kind of, for explicit biases we're aware of, we can try to sort of subtract that out of the data, or at least reveal if we think we can't. So our method actually says, if you can't satisfy a desired fairness constraint, it says no solution found. So then at least like, well, no, there's nothing that would kind of be equal on these measures. But I think one of the things that I think is a big challenge is that sort of still requires the end user to know what these different fairness guarantees are that you would like. And often there might be missing subgroups you've forgotten, or, sort of like, zip code is a proxy for many things, so there may be different features that are correlated in important ways with equity issues we care about. And so I think that's still a big challenge, the kind of unknown unknowns, that some of these things can end up with unintended consequences.
So to pick up on that, my work on fairness starts at the point where Emma just stopped talking. How do you think through the different definitions of fairness that apply in different applications? Because I think there is a general consensus that we want our systems that affect social settings and policy to be fair. But when you start poking at the definition of fairness, it often is not very clear what it means. And in the educational context, you can think of it in terms of, do you want average performance to increase? Do you want to reduce the gap? Do you want value-added systems? So a lot of the work we've done in the past 2 years, my team at RAND has been to sort of do a case-based exploration. So you take a specific application domain, whether it's criminal justice or specifically surveillance practices in post-incarceration, or whether it's in auto insurance pricing, or whether it's in recruitment practices, and then dissect the expectations of fairness in those areas and sort of see how you can, we focus more on the auditing perspective on fairness because we don't work at a large company with lots of data. We have to often go to third parties to get their performance data to audit that. So given the norms of fairness that we've defined, we've identified in those domains, figure out how to use data auditing practices to test whether the system behaves the way it's supposed to behave. And so we increasingly, when we talk to decision makers, and especially in government, about fairness and the use of machine learning algorithms, that question of what exactly do you mean by fair is the very first one, and that's what we're trying to address in most of our work. And I think in educational settings, we have to think through that also. Like, what's the right metric of fairness for a particular intervention in an educational setting?
And I'll take this in a slightly different direction. I think, at least from what I see, a lot of students at this point, I'm talking about the college level students, at least the ones I work with, they've heard of the issues of algorithmic fairness. They might not understand exactly where they come from, or they might not know how to mitigate them, but they're aware that there are big problems there. And one of the things I worry about is we don't want students who are training to build next generation technologies to think that that's the only place where these issues come up. So for example, there are basic things like universal design principles and accessibility. There are issues, there's a great series of blog posts that I like using in my class, falsehoods programmers believe about X. So there's falsehoods programmers believe about names, about dates. And even if you're in an intro class setting up a data schema for something, and you say, how are we going to represent a time? And what I see is most of the discussions are, do you use 24-hour time or 12-hour time? And if you go pull up this article, you'll see that, you've scratched the tip and hit none of the really interesting cases in the ways that you can make systems or bake aspects of bias into your systems. It's a different kind of bias, but it's part of this mentality of how to think creatively and broadly about how we bake assumptions about users into our tools and into our data. So I think it's really important for those of us who are involved in teaching computing to really push beyond leaving this issue kind of closed off in machine learning, because it's very easy to talk about it there, but that's not students' first point of contact with this content or these challenges as students of technology.
Oh yeah, go ahead, please, Osonde.
So this, yeah, the exact issue of making sure that these issues are not siloed off and it's not just the first contact point. That's dead on. I will wear my party run graduate school hat at the moment. The other angle we sort of take to try to prevent that siloing of concerns is right from the get-go, from the first week that graduate students in policy walk into the door, we give them a course in ethics. We make them more clear, we make them more aware of all the values they're bringing to bear every time they try to do a piece of analysis. It's easy to say you're objective when you use all the best data-driven methods without thinking carefully about, wait, the way I ask this question, does that embed a value? Does that embed an ethical preference? And so we start with that from the first day, and every time we teach a data science course in the party run school, or we teach a machine learning course in the party run school, no matter how much of the methods we talk through, there's always a period during which we talk about the ethical implications of the methods we're doing, or we're teaching. So yeah, it's important to keep these value-based conversations sort of embedded in all the data analytic machine learning practices we do.
I wanted to pick up on one of these. I completely agree with everything that was just said, and I also want to pick up on an earlier point, which was which Osonde was making, which is these sort of fairness guarantee, fairness definitions, and really sort of the objective of the machine learning systems themselves is incredibly complicated when we start to get into education and many other applications. I like to bring up some slides where I compare sort of the standard way that I teach reinforcement learning, which is there's a scalar single reward, you're just trying to maximize the expected sum of them, versus like the educational principles that are outlined in my son's school, which go on for 3 pages, you know, and include like discovering passions and like promoting equity. I mean, like, you know, it would be sort of literally like 70 different objective functions, right? Some of which only apply to populations, some of which apply to individuals, some of which are only measurable over 10 years, you know, and I think I laugh, but I think it also, you know, it's something that many of us really deeply believe in, many of these objectives. And I think it's actually a really big opportunity for machine learning and AI, because often we assume what we call, you know, the loss or the objective function is just given and we just move on. We're like, oh, predictive accuracy, or you maximize the sum of rewards. But in reality, we often care about constraints, multi-objectives, and it's going to depend on the application. And often we don't have methods that can deal with this richness, you know, because sometimes it even involves how we collect data. Can we fairly collect data for systems that are continually changing and improving, which is one of the issues we're thinking about right now. You know, what would that mean to do fair data collection over time for sort of evolving systems? So I think these sorts of questions are really important and really intellectually exciting as well, because we don't have methods to kind of, we have some methods, but definitely I don't think the problem is solved. And so I think that's another place where we could further engage with the NeurIPS and machine learning community to sort of say, look, we need these things so that these can be suitable. Because, you know, if I go to my child's teacher and say, I've got this great system just to maximize test score for this one test per week, you know, that's not really, that's nowhere near what we're trying to do in education.
So one of my actually former PhD students working on a project with me actually has brought to my attention this I think it's kind of actually somewhat actually famous paper now, who has the title "Man is to Computer Programmer as Woman is to Housewife," right? And actually an analysis of how these word embeddings actually have all these biases built into them because they're built on actually freely occurring actually natural language text like Wikipedia or Google News. Are we ever going to be able to use these NLP techniques? And maybe Emma, you might actually be someone I'll ask first actually about this. If basically there's bias in actually these texts, like, are we? Well, yeah, I guess actually can we fairly use these things, or am I going to wind up actually, if I incorporate this into my system, actually wind up actually grading girls differently than boys, or all these other things? What's the future of this, Emma?
I don't think, I think it's a complicated and important question. I don't think I don't think we have to have unbiased data to end up with unbiased systems. It certainly helps. And I think most of the data we use right now is from society. And of course, we know there's huge, problems and systematic racism in much of the data that we see. I think one of the things about that line of work, which is done in part by my colleagues James Zhao here at Stanford, is that I thought it was really cool that they found ways to transform it. So you could kind of subtract out some of these biases, right? Like not necessarily everything, but some of them. And so I think that's pretty exciting, because once you can put in, it sort of goes back to my point about multi-objective constraints. If you know that there might be some of these biases present, there often can be ways to kind of subtract out or reduce or kind of de-amplify some of these biases. And I think at least that should be the goal. Like, we hopefully will be no more biased than what we would have been with human decision making, and hopefully less. And so I think that seems very possible to me. That's not a solved problem, but I think that there's many reasons to be optimistic.
Oh, that excites me, because my son actually worked with Adam Kalai at Microsoft Research trying to figure out how to debias these things, and they gave up. But I got to read what you actually just referred to and share that with my son. Kathi, Osonde, do either of you have comments on this line?
I think the point Emma made about just because we have biased data doesn't mean we can't have fair decisions. I think that's an important point, because the starting foundation is society is unfair in many ways, and the goal of much of decision analysis is to try to make it fairer. So that's the state of the world. We have to make this better. One of the things that I do try to emphasize is if you understand the system of decision making, and you notice that one part involves training a machine learning model with biased data and definitely getting a biased model, a systemic understanding of the decision pipeline gives you more flexibility, more leverage, more intervention points for changing the outcome so that it's better and fairer. Increasingly, we see this in government practices. We can't control what comes in, but we can control how the decision is modified to be made more fair. That sounds nebulous, but it's my default perspective on all of this is the system helps you see more ways to make this better. And if you focus on just individual points, you're in trouble.
Coming back to the question about how we teach students to work effectively, teach budding technologists to work effectively in this, it was reminding me of something you do in software security. Is you do something called threat modeling, where you're looking at the various kinds of either attack vectors or risks or issues that could come up. And you do this threat modeling activity at the architectural stage of planning a project. So it's part of the requirements gathering phase to lay this out. And what I've been thinking about a lot lately is this idea of social threat modeling, and say, for the kind of activity that I'm about to build or the kind of product I want to do, what are the ways in which the kind of solution I'm putting together could have adverse impacts? And by having done that analysis before you get your hands on the data set, it gives you a better sense of what to check about the data set, right? There are ways to look and see if there's bias coming up in this data set in a particular direction. So when I think about educating students, I want to teach them to articulate social threat models. I want to teach them to test data sets for bias so that they've kind of done that homework before we actually turn them loose on building products. The downside is building products is, for a lot of people, where the exciting part is, right? I mean, encouraging people to plan and to test, especially when they're new to computing, like that's not where the cool stuff is. So if you really want to challenge, help us figure out if there are, large-scale database techniques that make those activities compelling and fun for people who are building software systems.
Like how to actually make it compelling and fun to be testing your systems for biases.
Make people get that adrenaline reward from having tested something well, as opposed to getting an app or something running that they can then show off.
Yeah.
So I bet Emma or Osonde actually knows something more about ways of testing our machine learning algorithms for bias. Do we already know some stuff about this that's worth surfacing?
I mean, audits are standard nowadays. So you essentially present a diverse array of inputs to the model and see how it performs on different, if demographic characteristics are important for fairness definitions, you see how the model performs in different types of demographics. I think it's the standard terminology for that is disaggregated evaluation of models. You can also sort of, another form of fairness is, another dimension of fairness, I guess I should call it trustworthiness, not fairness anymore, is this issue of interpretability. Like in some domains of decision making, it's more important to be able to say that everybody goes through the same procedure, so at least give explanations for why an outcome happened. And so there's a lot of work right now on explainable AI and the ways in which you can do that. I'm less sanguine about the prospect of truly explainable AI, but Emma might have a different perspective on that.
Do you have any thoughts on that, Emma?
I guess I don't. I mean, truly explainable AI, I think it's an interesting challenge, and I agree that it depends on the domain. It depends also how closely the AI and the humans are interlinked. I know that in some of my joint work with my students and my colleague Finale Dashi-Velez over at Harvard, within our healthcare work, we thought about sort of, if doctors are going to be using this, then it's very important that the decision policies be interpretable so they can be examined. I guess just to go back to Kathy's point, I think one of the areas that I think is pretty interesting, I haven't worked on it myself, is adversarial machine learning. And I wonder if some of the work there, it's not necessarily so fun to plan and, think really hard. A lot of people don't like to plan out, their software projects in advance, but it can be really fun to break other people's. And so, I think coming up with good test cases for other people's, or trying to derive ways to be adversarial or competition often can be very motivating. And I don't know if that's been done very much in computer science classes for trying to ways to make it engaging, to figure out what are the flaws. I think their approaches in verification and sort of, provably showing this will never, be breakable. And I think that can be quite powerful, particularly for high stakes applications. But for many other things, we may not quite be at that level, or we may not be able to prove some of those properties yet. And so being able to do extensive sort of adversarial testing and making that something engaging so that it becomes part of standard practice. And I'm not a practicing software engineer, so I don't know, maybe some of that is becoming more standard, but I think it would be great to figure out engaging ways for that to be part of sort of the standard things people think about when they develop software.
Can I make a suggestion?
Sure.
So one of the things we did earlier this summer was what we called an ethics hackathon. So you have this product, this data dashboard, that's doing lots of analysis in the background, and the developers are super excited about it. And we're like, you know what, let's give us about 2 weeks. We'll help you see all the ways things go wrong there. And the students were super excited about it because they got to sort of, I guess there's a competitive aspect. They got to sort of push down and sort of poke all holes in somebody else's product. So I think that's a good way. That's one method for doing the social threat modeling that Kathi was talking about. I had fun doing it too.
And coming back around to a tooling perspective, which I know is what a lot of people think about, as someone who's used some of these kinds of approaches just with basic writing examples and test cases in software development classes, one of the challenges sometimes is generating meaningful alternative implementations of something that people can test out their testing ideas against or try to break against. So that could be a really fun use of some of these machine learning type tools, is what are plausible mutations and variations that you make on designs that would surface certain kinds of fairness challenges and whatnot, so that you then have a whole family, say, of dashboards that people could be using in, break this, compare this, contrast that. That's a very time-consuming human activity, at least in the domains I know of, where I would have to imagine there are patterns and interesting things that you could be doing tooling-wise.
Can I actually use the last 5 minutes for us to think? I want to come back to the Zoom thing, right? There are literally 10, 20 million children probably on Zoom actually right now during this pandemic. And while this pandemic is awful, it also is providing some opportunities. Like millions of these Zoom recordings are actually getting recorded. Like, what are the opportunities possible actually that could maybe actually improve education or research around education, or maybe actually Could we do anything? Can we make any, lemonade out of lemons here? Any thoughts?
I guess video is data. And one of the approaches might be trying to surface more efficiently positive examples of good teaching. So you have all this teacher video out there, and maybe there is some signal of interest based on how many questions are popping up in the chat. And you try to say, okay, based on the signal of interest, how do we identify good parts of the video such that other teachers can learn how better to deliver the material? That's just a random thought.
I think these are great questions. I think I do think there's a lot of really interesting affordances that may not be possible normally that are happening now. So for example, we were starting to do a small pilot on distance tutoring this summer. And one of the things that my education colleague, Rebecca Silverman, was pointing out is that for professional development and coaching, you can, in this case, she could kind of give real-time suggestions to the tutor without the student knowing, which is really hard to do in practice. It's hard to observe, it's hard to, and so she could just, for student protection reasons, we always had 2 adults on every call, and so, but the more senior person would mute themselves, but they could be sending private chat messages to the tutor and be like, hey, why don't you try this, or this might be kind of useful. And so you don't undermine the authority of the tutor, but yet you could be kind of doing real-time professional coaching. And that was a human doing it to a human, but I thought, well, that's really interesting. Like, here is this way that would normally be really hard to do in a real situation, but you can do it here. And then similarly, going back to the case of, like, you could dynamically regroup people in different ways for breakout rooms, or sort of figure out how do you target time or effort if you're floating between different rooms. Because I think that the idea of kind of doing dynamic regrouping for kind of teaching at the right level could be really powerful here. Not long-term ability grouping, I mean sort of like for this session, or this week. And I think those things could be really exciting to explore in this sort of space.
One of the things I've really found fun in the Zoom setting, so I'm co-teaching this large intro class, and my colleague is doing all the lectures, and I'm monitoring the chat session. And we're using a specific chat tool called Prismia that one of my Brown colleagues developed. But I'm sitting here watching all these different private chat threads to the instructional staff coming in. There's got to be stuff we can be doing with that to go back and, for example, tell us how to augment these lectures next time. So that we work on, say, oh, we have to build out exercises on this and improve that, or maybe this is what you need clicker questions on, or something. And for classes that don't have a human sitting there monitoring all this stuff, how would you get a sense of what discussion is actually going on behind the scenes?
Yeah,
it does.
Give me that, I'll use it tomorrow. So.
Yeah. I will say it does seem like it brings up some really cool opportunities. I, for one, actually have a project where we're trying to actually make kind of like Google Smart Reply, who gives like 3 suggestions on how you could finish your email, or or how you want to respond to your email. Like, seems like we want systems like that that can actually maybe make some suggestions to teachers, particularly when they actually have other kids in different Zoom breakout rooms. Like, monitoring that seems like overwhelming. It used to be kind of easy standing. I did teach middle school, standing in the middle of my middle school room to look around, and I can do some level of monitoring. I know, like, I probably could tell those people are not having any conversation. There's no noise, and maybe I might be able to detect something about that group is only talking about Team Fortress 2 or some crazy game or something. I've already dated myself actually with my game reference. But anyways, it just seemed, well, anyways, I wanted to actually end on a somewhat positive note, in that I think there's actually, at this time, while it's very sad, actually, the pandemic is going on, it feels like there's opportunities for us actually to be developing technologies and using, NeurIPS actually sort of techniques to just maybe actually learn actually what works, and to build tools that would actually better help actually educators. I think I want to thank our panel, and because I know actually some of us have to run, and so thank you all for showing up.